So remember that the PR interval is representing the time that it takes for the SA node to transmit that electrical impulse through the internodal pathways, and then it gets held up in the AV junction, and then it's allowed to go through into the ventricles. So we want to measure that time. That means we need to again pull out our calipers, and we're going to go right up here, and we're going to find any P wave. I usually like to use ones on the left, and that's where we'll just go right here, because then I can move things to the right, and just like reading, right? We're reading the EKG. So I'm going to go from the beginning of the P wave to the beginning of the QRS complex. And again, this is one of those skills where you are going to get better with time. And keep in mind that it's like there's some slight variations that are going to occur from person to person because of where they place the calipers. But when we take a look at this, we're going to see whether or not it actually stays consistent. Does the PR interval work the whole way down this ECG? And it does. So let's move this up here. And when I am now measuring this, I'm looking to see what the PR interval is. So here I have I have the beginning of the P wave, and I have the beginning of the QRS complex. So here you will see that I have 1, 2, 3, 4 small blocks. Recall, each one of these small blocks is worth 0.04 seconds of time. A large block, one large block, which is 5 by 5, is equal to 0.20 seconds of time. So this has 4 blocks. So my basic math is 4 times 4 equals 16. I just have to account for my decimal point, and it is at 0.16. So it falls within our normal range for a PR interval. That's what we're measuring. And then that's the question you have to answer is it normal or abnormal? Consistent or not consistent? Well, let's see what consistent means. So let's bring our calipers down here to this bottom EKG. And we're going to take a look at where each P wave is. What I notice about this is that there are P waves. There's a P wave here that doesn't have a QRS, but I still need to measure what the PR interval is. So let's make sure that I account for every P wave. And I'm just, again, doing a P to P, making sure that they're there. So there's another P wave that does not have a QRS complex. Let's take a look at this. Let's see how this actually works a little better. And I'll mark these for you. Okay, so here is our PR interval. And when I look at this, it falls, and since I can't really see it really well there, I can move it up here. And that's 3 blocks, so that's about 0.12. 3 times 4 is 12 at the decimal point. Okay, so that one was at 0.12. And just for this sake, we're going to say that this one here is 0.12. This one, a little longer. This one looks like it went to 0.20. Okay, so we'll mark this one here. Now let's take a look at this last one. It just doesn't want to cooperate very well with me today. In this case, we're looking at 6 blocks. Okay, so 6 times 4 is at 0.24. So what I notice here is that the time from this PR interval to this PR interval to this PR interval has gotten longer. So if you're looking for descriptions of it here, you can see kind of how these things go, right? So they get longer. There is a definition for that. And there's an EKG identification definition for that. So that gives us an idea of things that we can look at. Again, following those rules, making them simple, that we're just measuring time. That's time going across that horizontal line, right? That's what we're concerned about, okay? I'm not really concerned on the vertical axis whether or not it is anything for amplitude right now. I just want to know, is it positive or negative? Just helps me identify what those waves are. Let's move on.